Hey everyone, what is up? Who was all here today? Say hey in the chat. Let's go back here. Let's restart MuBot. If you are here, MuBot crashing the world behind us right there. If you are here currently in the chat, feel free to say hey, and we'll start learning what everyone will learn. Sorry, yesterday was short office hours. Hey Braden, what's up? 474 assignment just got released. Got that put out here due Tuesday. So people should see that announcement coming out for them right there. Mary, good to see you. Mary, what questions? If you have any questions, let me know. Stat 1 projects are getting graded up as we talk. Yesterday I had oral surgery, so to say, or I guess, they put crowns on my teeth, or temporary crowns. I did not know that when you get crowns, you first get temporary crowns, and then you go back in. Hey, Cliff, good to see you here. Let's throw out some 20 points. How is everyone doing? Feel free to ask questions. Brian, I'm in 474, and I'm working on this. I'm in 475, and I'm working on this. I'm in 201, I'm working on this. If you have questions... Crown's gonna fall. If you have questions right now, let me know. You can't even tell. They did a good job. Just not close my mouth. It's so weird. I'll get used to it. What questions do you have right now? Let me know in the chat. If we want to send you our 475 project idea later, can we direct message you on Discord? Of course, Braden. Braden, great question right there. You can direct message me on Discord. Looks like I've got 4 Discord messages right now. Let's see if they're important. Let's go over here on Discord. Right here. Yes, let me go right here. Someone says 475 roll. Someone wants the 475 roll. So let me go members joining. I should see them recent. Where are they at? Oh, they might have changed their name. Where are they? Yep. Say something like hi, general chat, and I will give you the role. There we go. Message them that. Hey, opens in R. Inside of our studio. Click file open. Let's see. Oh, Cliff. Yeah, I see it right there. Yeah. I just saw that, Cliff, right there. I'm replying to it right now. Oh, Cliff's talking about the one message right there. So what you want to do, Cliff? Here, I'll head over to the main screen. So extra credit. I guess I got to give extra credit right now, right? The screen says it. I got to do it. So are you on a Mac or a PC, Cliff? You can change the way files are associated. If you're on a Mac or a PC, you want to go to like the properties of a file on a PC and go to the way that the file is looked at and go to change default. But there's ways to change the default. But also, if it's opening inside of R, you don't have to let it open inside of R. You can go to File, and you can just go to Open File right here. You're on a Mac. On the Mac, it is... You got to right-click and go to like Get Info, and that should have the default opening. Try going over the file that you downloaded and go to like Get Info on it. And I think under the Get Info, it has like opens with or something like that, or has a default open. And then you can select for that file type. Does that work right there, Cliff? When you go to click on the file, and you'll want to like right click, like 2-finger click on it. A thing should pop up that says like Get Info on the file. Like it should be on the list of things. You go to Get Info, and then under the Get Info, it should have some sort of like opens with by default or something like that. And if you change that, that should change the file association. So whenever you have a .rmd file or .r file, and then you want to select RStudio from that, tell me if that's working, Cliff, and that'll make it so then when you download a file, such as an RMD or an R, you can then have the default opening to that certain program. That's kind of good stuff to just generally know if you want to create a default opening. Is it seem to be working right there, Cliff? Great questions right there, Cliff, to help out with the default opening of a file. So hopefully that's working. I could go through it on Discord here in a little bit if you're solving problems with it. Like you're like, I'm so close. I don't have a Mac here to demonstrate, but on the Mac, I believe it's right-click to bring up file info on that file, get info, and then there should be a default like opens with or use this by default. It's like on the bottom of the list of one of the things. Hopefully Cliff comes back and says, it's working. I got it. The default. Let's go back here to Spruce. What questions are there? You know what I might talk about? I might talk about some lapply here. We didn't cover that in class. It is in the notes. 474, 475, 201. If you have questions, let me know. Let's see. Let's talk about a little lapply right here. Let's look at lapply. What is this lapply? What is lapply? Let's go down here and look at the assignment. Kind of a good thing to talk about since we didn't talk about it in class. It is in the notes. And let's go talk about some lapply. I gotta turn off the extra credit button. Is it gonna turn on every time now? I'll have to fix that. Gotta do as the screen says, right? So lapply is a function that applies something over a list. So what does lapply do right here? Takes whatever we're doing, applies over the list. So let's go look at the format of lapply. It says the class of the first two columns of education. Well, we'll go ahead and solve this one. So with this, we're going to type lapply, and we can see what's going on here with the lapply. There's the snippet for it, and it says it takes a list and it uses a function. So we can give it a list, and then we can give it a function to do repeatedly over that list. What's interesting is data frames, and I've got a totally different data frame up here. I'm going to use the data frame. A data frame, I'll use sub1. A data frame can work as a list. It'll do it right here. And it'll do it on the columns of the data frame. It'll treat it like that. It's mad about that function thing right here. This is the function we're calling. And if I recall correctly, we don't want to put the parentheses around it. And guess what it did? It just printed out for me all the classes of each of the columns of sub1. So if you look at the output we're getting right here, we're getting factor, numeric. Next we should see integer. There's an integer, and that's right there. So let's go ahead and doing that right there. We might even be able to do this. Let's go right here and go to head. And I think this should work. There you go. There's the head of each column. So it's going through algorithmically. And so lapply is a really neat function. It's meant to be list apply. We could probably do smart apply. Smart apply right here will return back. It kind of looks at what you're giving it, and then it returns basically that. This is smart apply. And it applies, once again, we're getting the head of everything, which frankly, we could have just done head of the data frame and get the same output. So get the same output here. Looks slight. Oh, it's just doing this differently. Different return a little bit. Very similar return. But sapply is smart apply, which is a kind of a, sometimes maybe a better way, because you've got like, I'm thinking of Kenny. He called it Laply, Taply. I was like, no, it's T-apply. And he's like, no, it's Taply. And here's Saply. I think there's another one. Laply, Slaply, Saply. I was like, Kenny. He's like, no, I'm going to run Laply and then learn Apply. There's the apply function. So you got table apply, list apply, smart apply. Is it Daply? Oh, we don't have Daply. Is there Maply? Yep, matrix apply. So this is going to be, is it matrix apply? I don't use Maply much. Is a multivariate, oh, it's a multivariate apply. Is a multivariate version of sapply. Applies function to the first elements of each argument, the second argument, the third argument. Cool. That's it's not matrix apply, it's multivariate apply. So this is way more in depth than we need to go on the apply family, but the apply family is really good because you can just run a function on a data frame. You can run a function across a list, and we could do something right here. Like, let's say we have a small data frame. Like, let's say we collect data on students right here. So let's go to students data, and we ask students their height. So we're going to make a data frame. Good practice on knowing how to make a data frame. And we go here to the height of students, and the height of students is equal to random normal numbers. And the random normal numbers are going to be 100 students we talked to with a mean height of, let's say, 68 inches and a standard deviation of 3. We're going to do the same thing for weight and GPA. We're just going to do normally distributed data. And we're just making a data frame right here. If you have questions, let me know. The weight of students is going to be 100 randomly generated weights with a mean weight of 140 and a standard deviation of 25 pounds. Now let's go 150. It wanted to do, sure, 160, it wanted to do that. And the GPA, so we're making a data frame right here. 100 observations of GPA, where the mean GPA is a 3.7 with a standard deviation of 0.1. You can view these vectors right here by running this, and you can see the GPAs we're creating. Now, they're pretty long decimals. That's all right. So this will create a data frame of students right here. And let's look at our data frame of students. You can view it right here. Another thing we mentioned in class today is the structure, str, called the students, lets you get a little glimpse. Turns out it's to dplyr right there. Glimpse is a smart function which is in dplyr. So you need to have your library dplyr running right now. And we go right here and we go to students. And now you get a glimpse of the data frame. So some people prefer glimpse to structure. They're going to return the same sort of thing right here, or the same idea behind them, where glimpse is going to augment to the size of the screen, i.e. if I make the screen bigger, it will augment, i.e. get bigger. If I make the screen smaller, it won't actively do it on what I just created, but if I have a much smaller screen right here, it'll print the output such that it fits to the screen, which is really one of the nice things about glimpse, is that you get the output per size of screen you have. If you change your screen size, it's going to change the way the output is. One of the nice things about glimpse, str doesn't do that. str is going to be the same sort of, I think it gives the first 6, which can sometimes wrap the screen, especially, at least with this data frame, it's not. But str will wrap the screen right here, and glimpse will not. Really neat thing about glimpse. That's probably the coolest feature of it. It also returns a tibble. More on tibbles at another time. So we have our data frame right here, and the data frame that I created is literally just an Excel spreadsheet. A lot of people get freaked out in these classes because they're like, what am I dealing with? But all we're working with right here is an Excel data sheet. It's just Excel data. Not literally, but I think we all know what Excel data looks like. That looks like Excel data to me. So what we're going to do right here is we're going to think about, what if we want the mean of this column, the mean of this column, the mean of this column? Well, we could go through here and algorithmically work through this. Go back to number 5, we're working with lapply. We could go down here and we could say, give me the mean of student, because that's my data frame, vector height. And if you notice, we get right here the mean of the height. We go right here, and we could go to the mean of weight. We go right here, and we get the mean of GPA. But we could go to sapply, and I think this will give me what I want. My list is going to be the data frame I'm using, and the function is going to be mean. And look what we get. It just went through for me and found the mean of each column right there. Now, what's the difference between sapply and lapply? Sapply is the smart apply, and lapply is list apply. So it's meant to input a list, which a data frame can pass as a list for the moment. It'll say, okay, sure, whatever. But lapply also outputs a list. So you're meant to input a list, which it's taking our data frame as a list, but the output you get will be a list. So the output's going to look different. It's going to look like a list right here. But let's say you don't want this to look like a list, hint for the assignment. You can go here to unlist, and now you get basically the same thing. It's just about the 3 to 5 ways to do things that we always talk about, that you only need one way to do things. You only need one way. This achieves the same goal right here as this. So we achieve the goal one way or another to put output like this. And this right here is, interestingly enough, something we also talked about in class today. I will throw 50 points in right here if anyone knows specifically what this is called. Let's put on a little music. Who knows what that's called? That's a what right there. What did I create? It's a specific name of it. Giving hints right there. This is this. And this means it's a what? Braden right there, 50 points. You're right. It's a named vector. Exactly. That is a named vector. So return back a named vector. Good job, Connor. Good. So DF are degrees of freedom. So this right here shouldn't give you up. No $. Should be able to go here and go to weight. And then we can get the mean of weight. So it's returning back to me a named vector, as in this vector has position names, like position 2 weight is called weight. So it has a name to that position. Good stuff right there. Is this making sense how to use the apply function? A lot of times people use it on lists. I could go back to my Pokemon example and probably use the lists. That one. Oh, data frame, yeah. Yeah, so what's interesting is it doesn't return a data frame, because smart apply, I think, usually tries to take what you give it and return back that. We could check what it's returning right here. And let's go to class of it. It's returning a numeric vector, it looks like. So maybe type up will tell us a little more. It's that's double decimal precision, which means that's kind of for the encoding right there. Why do you want to unlist it after doing lapply? because it returned a list. Like a lot of times you might just want to work with a vector. I don't love working with lists. Basically, anytime I go to a list, I want to get out of a list as soon as possible. I used a list earlier today for my Pokemon generator, but I often try to leave lists as soon as possible. I just don't. Lists are not a format I generally like to work with. Everyone has their preferred format. I like data frames. I like vectors. Lists are important. The returns you get. You know what's funny here? Can you reference a name vector via? Great, Connor, right there. 20 points. Yep. Was that? That's Connor, right? Yeah, of course. My brain. I had, if you didn't know, I had to get my teeth capped yesterday. I had to get crowns on my teeth. Yep. But because it was annoying. Yeah, it's annoying. And what you'll get a lot of times is your LM output. No, you're fine. Ask those questions. Yesterday I had to go in to get 2 crowns and 2 cavities filled because I forgot to floss for like 5 years. Enough on that. But this right here, this M, as I keep hitting my teeth. Yes, it was not fun. It was 3 hours of playtime. What are you doing up there? So this creates a list right here. This object, this M object right here is a list. You can actually go through and see what the list contains. It's got all your residuals and all this stuff right here. So you can get your residuals of your model going back to little 320. Brian's digits right here. What have I done? Okay, good. Wait, what? Oh, is this the data frame I destroyed? Okay, I destroyed that data from earlier today. Yeah, it's there's a lot of really useful small things right here, and knowing how R sees the object. Like if you go and check the class of an object, which is in this assignment also. Oh, it's class LM. I didn't know it'd be class LM. It's a linear model. That's what it's telling me right there with class LM. It's a list. Type of is returning its class linear model. So R knows how to handle that as a linear model, like when it summarizes it and everything. But it's type, which type of is returning a little bit. Which I might actually look at the difference. Connor, Brian's greater than Galactus. Connor, do you have ideas on the difference between class and type of? I mean, they diverge a little bit in what you get. Like type of, I think, gives a more specific, like especially when we look at type of on, like if you go type of on this, I think it's going to say double, which means it's double decimal precision, which goes to the encoding destroyer of data frames. So type of goes to like a deeper level to the computer programming side of it. And then class is how R is passing through that object and how it's going to handle it and use it through certain functions. As in, very important to know with class, if we have something like our survey 10 data and we take a vector like gender, because gender is a factor, which means it's a categorical variable, stat 1 review right there. When we pass this through summary, we are going to get a table. So we get a table right here. But if we take something like GPA, which is class numeric, then when we pass GPA through summary, we get the 5-number summary along with the mean. So you get different output depending on the class. So class is going to tell R, hey, this object is this type of thing. When you run a summary, do this sort of thing on it. Class is just general compiler knowledge, kind of subjective, it quickly, and handling it properly. Awesome job right there, Connor. Sorry. The pain as I close my mouth. Type of would be the object subtree. Oh, so it's like even deeper further. So Connor's giving some great advice right here. Connor, just wealth of knowledge. So like type of is going to go even deeper. A lot of times we don't need to know the type of. Well, I mean, if you're like hardcore programmer, you know, if you're some Stat 1 hacker man, you just want to go and know that type of, then yeah, definitely get down to the type of and drill down further to say like how exactly is it seeing this? Is this double decimal precision? You know, what encoding are we using on this? What exactly is going on right there? So back to basic. Really good. So really good stuff there on the lapply, sapply, maply, saply, daply, taply, laply, all those things, as Kenny would say. Kenny he was killing me on that. He just walked in and he was like, do we need to use saply or taply here? And I'm like, Kenny, man, what are you doing to me? If you have as.vector and unlist m residuals, would you just have a vector of the residuals for each data point? Good question right there. Let's go look at this. So it was a little bit about the lapply and all that good stuff. Is map? It's not matrix apply. It's multivariate apply. Do I still have that help file up? It's multivariate apply. I thought it was matrix apply also, but multiple lists. It's multiple apply. So it's a multivariate. It's multiple apply. I would be careful. Apply as vector to a list. Yeah, let's take a look at this. Connor's thrown some great advice. I've never used Maply before, but there's the Saply, is the multivariate sapply. So the question is, if you have as.vector and unlist m residuals. So we've got our residuals stored from a model, little 320 right here. And there's our residuals. And you're unlisting them. Well, this is not currently a list. So this is currently a vector. And so it didn't do anything. I didn't think it would. But if you go to unlist on this, ooh, this is going to be interesting. Okay, so this, here, let's store the object here and store it into test. I just store test when I don't know what it's going to create. Oh, that's, ooh, I don't want to deal with this. Okay, so this created a large list, but I unlisted it. Let's unlist test. This is a bad idea stacked on top of a bad idea. I didn't do anything different. Let's give 20 points out right here because this is pretty interesting to see what's happening right here. So using apply. Oh, okay. Let's check this out. Yeah. Let's do this. So let's go here to apply, and we'll go to lapply because it is a list currently. We're gonna apply to this list, the unlist, and do we get the same thing? What? Let's do identical m comma test. Oh, it's false. Something about it's changed apparently. Because if we were to take right here and store just test2 into write m, something about it's changed, and that looks to be part of it. Error. Oh, I didn't type it rightly. Okay, something about it's changed. So I wouldn't suggest that. It's interesting what we're seeing right here. This is a vector right here with attributes attached to it. The terms has attributes. I think it's removing. Here's test 1. Here's test 2. I don't know what about this has changed. Nested unlist. So where are you saying I should nest the unlist? This is such a good question right here. So where should I nest? Maybe it is a list within a list. Yeah, so we need to. So these right here. So we can. I think they are lists within lists. So because you do that, and it's something else. Yeah, I know, right? So maybe so we take what this was, treat this as the first object, treat this as the first list, and then we call here the argument. Nah, it's still giving the same thing for test. I don't know what it's doing to it, and I don't know. It's interesting. This is a good stumper right here. I wouldn't. I like, depending on what you want, I can get certain things out of this. And what I would do if I'm going to take my residuals out of this, like if I really want my residuals, I might go here to residuals, and I'm going to go to the residuals. I know, right, Connor? This is a stumper. We got a pro in the chat right here, Connor, and he and I are both stumped. I might just store the residuals right here. So if you wanted to, let's say someone wanted to algorithmically go through and wanted to take all of the things here. And you notice we're calling it kind of like a data frame. Hey, let's change the lapply to an sapply, and let's just see if it can smart apply. So we're going to unnest this, which means we just put code inside a code. And then let's see what happens if we run it with an sapply. We get the same thing. Let's go tapply. It doesn't like that because that's not a good idea. Let's go mapply for multivariate. It doesn't like that. So we're getting the same thing right there. Recursive equals true. Is that another argument right here? Let me go to lapply. Recursive equals true. Where's recursive equals true go? I don't see. Is it gonna? I hate it when arguments don't pop up. Okay, it ran, but it didn't do anything. Yeah, okay, that is an argument. I just checked to see if it is, if it appears. It's not doing it. This is such a great question. This is a good stumper. 20 points for stumping Brian, stumping Connor and Brian. Really good question about, like, it depends on what you want. I was using an influence plot because I just knew it only gave one output, position of outliers, but this gives a lot more options. Yeah, actually, let me show you something really amazing right here. If you want to see something really cool, watch this. I think, and Connor, you probably don't know this also, Tibble of our model, really, what does Broom have in it again? Did I already overwrite the model or something? Let me go to glimpse of the model. Oh, we don't want that. I might have destroyed the model. Let me see. Let me create the model. This was craziness right here. Let me create my model again, and let me show you something new that I was looking into. Height, weight, and I'm hoping to make more changes and advancements, but I need a moment to make those. Okay, it should be... Should be tidyverse. There we go, list. Oh, wait. Oh my gosh, he's doing a tidyverse right here. Let me look at that here in a second. We'll go look at Connor's code. Connor's just destroying it with some tidyverse, with some piping. Map, df. Okay, wait, so do you already have it? Tidyverse library, tidyverse first. Wait, we'll go look at that in a second here, Connor. Where is it? Tidyverse. There's some tidyverse options for regression. Oh, here it is. Is this the one I was looking at? No. Trying to find one thing here. The problem is you can spend like a night coding and then you'd be like, oh, I totally did all these cool things. And then you forget to like write them all down. And then you've got all these functions you used once. Oh, here it is. Here we go. Here we go. It's tidy. Oh, we got a little Broom. There we go. There's the model. And then... Oh, and then you can glimpse it. Am I going mad here? And I think this actually did output I want. Okay, let me change this and let me call this test now. It's a list. No. Am I going mad? I think I'm just going mad. What did I one time see? I had a really good way. Brian's brain's turning off. Glance. Okay, that gets us the R squared. That gets us the summary statistics. The R squared adjusted all this right here. So we got glance, tidy, and then there's one more. Augment. There we go. Okay, Connor and Braden, I think. Look at this. And then I think Connor's getting my help for the next part of this. So what's really cool, and I was looking through some stuff. So it's Broom is the package we want to use. So take a look at this Braden right here, and then we'll look at Connor's right here. If you look at what Augment gives us, Augment gives us all of, you were talking about influence plots a second ago. Augment gives us all of the observations of the x variable, the y variable, the predicted for the individual, the residual for the individual, the leverage of the individual, the z-score. I know Broom's a pretty good package, and then the Cooks, and it's really cool. The standardized, the studentized residual for the individual. All this right here is given to us pretty quickly. And there's the Cooks, so you can find out the biggest outlier in the model. Which when we go to our influence plot, it's going to be this individual right here, and you can see them in the influence plot. So if we go to our influence plot via reg class, we can easily see the most influential point is this person down here. You know, they've got pretty large leverage, which is the hats. The 0.013 is towards the upper end. There's bigger leverage, but like the person with the highest leverage is actually well predicted. So if we go to the person with the highest leverage, which is this individual, they were predicted to be 78 inches tall or 78.6, and they are 78.6. If you can see, they're a tiny bit above the model. It might be hard to see where the model's at, but that person's a tiny bit above. The prediction, or no, excuse me, they are a tiny bit below. Here's their observation. Here's their prediction. So they are a tiny bit below the model. And we could show this even better if we go to AB line and we want to go horizontal equals 0 and go col equals red. So this will put a red line through, and now it's easy to see they're the tiniest of bits below. They're at 78, and they're predicted to be 78.6. Yeah, the augment thing is pretty cool, and I was looking into this as I've been looking into more things, especially with time series. Thank you so much, Connor. Connor sent me so much stuff. So I'm trying to do the newest, the greatest stuff, because there's a lot of stuff I'm looking to update with reg class. But you see the 4 influential points right there. So that's what augment gets you. Tidy is going to get you just some summary stats, I believe. So we see right here the summary of the model with the intercept, with the coefficient of weight, and then we get the standard errors, and then we get the t-statistics. I wish it said t-statistic up there, and then we get the p-values. It even gives you finer granularity on that p-value by giving you the -70, letting you know that that's scientific notation, because usually in R, probably Connor's seen this about 1 billion times, is you get the classic 2.2 e to the -16. So rather on here, so what's really cool about this is you get more granularity, you get a better view that this is ridiculously significant, and you only get the output right here of the model, which basically you're just looking at this right here. So you're only getting that right here. So it's a tidy version of your model. But then when you go right here to the glance of it, just overwriting test a billion times, the glance of it is just going to give you some important factors, which we get the AIC, which is super important right here. And this should be a Tibble that it's outputting. Yes, it says it's a Tibble. So the Tibble right here has all these important values, which we could call. And yeah, it's just a one row Tibble. Tibbles are basically smart tidyverse tables. And then we're going to do Connor's thing right here. But the glance basically gives you summary stats. So, comparison metrics, model evaluation metrics, because you get your R squared adjusted, your typical miss the model makes, this is the RMSE. I wish it didn't call it sigma, but we can confirm right here that that is the RMSE, residual standard error. You get right here the, sigma statistic. Oh, that's the F stat. Ooh, I don't like that it calls it statistic, but that's the F statistic. I even got confused when I saw that, but it's the F statistic. Here's the p-value of the model. Here's the degrees of freedom. Here's the log likelihood, and here's the AIC. So we don't get AIC or log likelihood from this output. Tidy is going to give you model parameter estimates. And this right here is values in the model, like residuals, leverage, and influence. For short, there's other things it gives you too. But pretty cool stuff right here. And Connor's got the thing right here. I need to load library, which I think I have. I think I have library tidyverse. Deleted studentized residuals always trip me up. It removes the point and calculates the theoretical. Yes, exactly. I think one of those was the deleted studentized residual. And just think about, studentized means standardize. I don't have tidyverse. So I'm going to reinstall R all the time. And divide that point by, I don't have tidyverse. That's how you install a package. Here we go. So we've stored. So Connor, let me take your code. Tidyverse library. Oh, the spacing. I see what you're saying. Sure. Did it do it? No. It's one of those buttons. Up. Installing a ton of stuff. Whoa. Yeah, Broom's pretty neat. Broom's a newer package, I believe. Whoa, what are we doing? There we go. What did we install, Connor? And this is, someone asked earlier today, why might we use something like this right here? And this is a good point. Tidyverse is like a super package. It's going to have all these Tidyverse things. You would have your list and pipe the model into the object. Yeah, I see the, yes, I think. I see what you're saying. You're piping it into the mapdf. What, I don't know what the mapdf function does. I'll have to look at that. And so let's take a look at that here. So why, and Connor, I want to hear your words on this. Why might somebody run this right here? Like, why might somebody go right here and go to like ggplot2? I gave an explanation in class. Why might somebody go in here and do this? Why instead of, we want to run alpha? And so why might somebody, which you see we can't run it right there. Oral surgery is so much fun. Why might somebody run version 1, and then we'll do the example right here, over version 2? And here's where you get to version 2 right here. I have my answer for why someone might do it, but it definitely came up in class. These will both get you to the same objective of just getting to the function inside the package. And especially my answer, which Connor can say if he agrees with, especially if you have a larger package. I don't really do this. I just load the package. I use version 2 99.9999% of the time. But if you have a larger package with a bunch of things, you just want to call one function. So this reaches inside of the library without initializing everything in the library. So it's a lighter load on your computer, which, you know, it just depends. You want something to run super quick. You only want to initialize one thing. You grab that one function and you say, that's all I'm using. I think that would be a prominent argument, would be consistent results. Yeah, and that might be it too, because you're always, and then actually, good point, because maybe there's a alias, I think I'm using the right term, right, Connor? Maybe another, like Brian's like, we make a function right here and we call it alpha. It's going to get mad at me in a moment. And we call alpha right here, and we go function, it doesn't take anything, and it just says, let's go to cat, and let's just go hello. And then we create our alpha function. So now if we run alpha right here, we get the hello alpha. But if you run alpha right here, you get the hello alpha in the ggplot library. So I've created an issue right here. I've got my function defined in the user environment as alpha, in the global environment as alpha, my user defined function, but then the function alpha in ggplot2 is a different function. So Connor makes a great argument too. Consistency of results, you know where that function is coming from. You don't run into big issues with this a lot of times. I should maybe code like this more often, but you will be telling it where the library, where the function is located. So good stuff right there. Good answer, Connor. And then let me grab Connor's code. So Connor's saying the LST is the list. We lost the space right here, so we're going to add in that space. And so there's the loading the tidyverse library. Wait, why don't I have a function? What am I doing wrong, Connor? Why do I not have a function tidyverse library? The dot operators can be used to reference without library. Exactly. Why do I not have tidyverse library? What have I done wrong here, Connor? Is loading. Boom. Let's start some 20 points. Braden, great answers right here. Braden and Connor, great both being here, just practicing some coding on this Friday. I think everyone's taking a little Friday off right now. The new assignment's released. We can go over any part of it. Just use library. Yeah, that's why I should have wrote. Oh, the other space was lost. I see what you're saying. That's what I see what you're saying. Yeah. I was like, what? Yeah, just run library tidyverse. Okay, we got that up and going. We got our list right here. This is going to take tilde dot. So we're just taking everything right there. Our list is the model. Is it not? Okay, what am I doing right here, Connor? We should have everything up. I don't know the mapdf. Let me read over mapdf real quick. Oh, it's in the per. Or have I uploaded one of my packages that shouldn't be used right now? Always returns a list. The map function transforms their input by applying a function to each element of a list or atomic vector and returning an object of the same length as the input. Man, per is... I've got the cheat sheet for per. So try not including the 1 through 3. Oh, I didn't... There's no... It's mad. Here, let me look at my per cheat sheet. I'm going to go to the per cheat sheet. People think I put cheat sheets online for students. I put cheat sheets online for myself. You need cheat sheets. You need things that walk you through how to do things and say, oh, you do this. So in 475, I gathered all these cheat sheets right here. What do you think of that, Connor? They have access to all these cheat sheets right here. So they can go download the cheat sheet, and you can see right here, we are working with the per package. Oh, there's my video playing in the background. We're working with the per package right here. And is it... I see I set a limit. Oh, so you could... Is it all a list? Yeah, that's the thing. Is, you know, we could plot... we could look at this. I think the problem is the object M... It's an LM, and I think that's the problem, is that it's an LM. So I think that's the problem, Connor, is it sees it as an LM, but it's a type of refers to as a list. The issue might be, that's what's so weird. See, it's gotten it a bunch of different things. So it's got, the list has in it because lists can contain different things. Like it feels like a list. Go ahead, Connor, and try to take a model and just turn it into something. Working with lists. So many things right here. Modify function behavior. Let's look for, oh, there's the map. So many things. Use the per map2, and pmap to apply a function that returns a return-wise. Because we're trying to get this to unlist right now, right? We're basically just on a crazy mission right now to do something that's really not going to even be that. I think your path with Broom is more appropriate the more I look at it. Oh yeah, Broom is really good right there. Broom's got a lot of great stuff, and that Broom's just a really nice package that has a lot of good options. Like everything we're doing right here is just to get out like the, you know, the coefficients. Cool. There's the coefficients. You can get everything very easily doing this, but I'm surprised the unlist doesn't work on it. Do we just run unlist on it? Is this what we did first? Problem is we get a ridiculous amount of output here, and you're getting everything unlisted, which is not kind of what I want. I want it to be, yeah, returns a list, and it just puts everything out into one thing. I mean, I guess that's what it should do, right? I mean, I guess the simple solution was just unlisted. Okay, wait, Connor, I have an idea. That's literally it. Connor saw it too. Okay, the answer was a for loop, which we'll start talking about in 474 next week. I literally was thinking that in the exact moment you put that, I was like, okay, let's just do it algorithmically. So we need to look through here, the length of the list. Let's go to the length of the list. It's length 12, so 1 through length of our list. We'll put a placeholder I to change through what we're going through. And so now we need to take and let's create right here. Here's something I don't know how to do, Connor, which, well, like, where do we want to store this? Where do we want to... I guess we could create a variable. Or it could have the name of what it's doing. So we need to get the name. Always write your function outside of here. Let's just go here to the first thing in the list, which this will be list position 1, which is this right here. Let's go to the name of it. And the name, it doesn't have a name. Does it seriously not have a name? Or do I need to do this? It doesn't have a name. How do you get... What is the name of something? See the lengths of the concern. You think the length will be the concern? Because data frames will not handle if mismatching. Yeah, oh yeah, no, we can't store it into a data frame. I'm going to store it into individual variables and create all these variables in the global environment, and I'll turn it into a function. Get names of lists are... How do we get the names out of it? Extract names of list objects. Someone's doing an lapply on it. Amazing. We got to go back to lapply. I just want the name. They're writing their own function. They're making a user-defined function. Is it really that much work to just get the name? Require function, require word cloud. Where's their function end? Oh my gosh. You gotta be kidding me. Oh, it'd be name, double bracket. I thought I did the double bracket, did I not? Or is it names? Oh, and I'm not doing object. Okay, so let's go to the first one. Okay, so that's the names of the things inside of it. I might have actually been doing name by accident. Oh, look, Connor, it's that. Was I really doing name? There's no function called name. It's names. If you're watching this right now, Brian forgot to use some autocomplete right there because there's no function name. There's names. So that's where you get confused and you're like, it's not running. So this... I know, right, Brayden? It's so easy. Just forget Nest. You're like, name, and it's like, Was it telling me no function, or was it just saying no return? Oh, could not find function. Maybe I should read what it says. Yeah, yeah. I can make these easy mistakes right here. So I wonder if. Let me try something. As dot character. Which, you know, it's already a character. I don't think this will work. Oh my gosh, did we just do it? No, we didn't do it. Oh no, did we? No. Ooh, what have I done? What have I done? What I want to do right now, Connor, to write my loop, we're almost done with this, is I want to write so it can store into this. So I want it to store into, is there like an as dot object? No, I can't do object. How do we tell it this is going to be an object right here? Any ideas, Connor or Braden, on how I'm going to tell it this is going to be an object? Like, I want the name coefficients to be an object. Like, I could just easily go here and say coefficients. Like, I could, like, this is my objective. That's my objective right now, is that when I say this, because I'm going to have it algorithmically go through and create these objects right here. Problem is some of them need to be lists. This is a deeper task than I thought. Super save? Well, we're not in the... You think super save will do it? I don't think super save will do it. Wait, why is it saying M's not found? Object M. It doesn't like that. Yeah, I don't know either. Tell it to go directly into cache. How do you tell it directly to go to cache? Let's see here. Turn string into object in R. How to convert a string in a function into an object. Okay, here we go. Okay, so someone's talking about it right here. They've got like 4 different ways of doing it. Let's look at this. I would like to convert a string that I pass a function into an object or column names. I know that this works. I don't want to answer. Eval, parse text. Okay. We'll just remove out their arguments and put it in for ours. So they've got right here, this might as well be X. We're just going to store this as X. And let's go there. And then that. What? What's they mad about? This has been a very big rabbit hole. There's that. Oh, is it mad because we don't have a DF right now? I think it's mad about that. Let's go capital DF. Null. Okay, we're getting somewhere. Text equal paste, eval. Let's remove out this because we don't want to store to the DF right now. Let's go right here to the sep, which is set by default. Okay, we're getting somewhere. Eval parse text. So now let's store into it. Let's store the vector 5, 10. And something happened, but I don't think it did what we wanted. The text right here should be coefficients. And if we run coefficients, we don't get the values. It could be that we're naming it coefficients. Let me try a different thing with a different thing here. Let me go to this one, and that's called volume. And so right here, volume should appear. Oh, man. We've definitely hit a... I know it's getting complicated really quick. We've basically just been trying to do a task that we don't really need to do, but I like trying to do things that we don't need to do. And we have to get our code to work here before we can throw it in the for loop. We need to get an example of it working on one of these. So let me look again at this. Convert character string into object names. This is 2002. I'm not looking at something from 2002. That's not happening. 2002 doesn't have the answer. RStudio community. I do it all the time. Exactly. This is the fun of coding. Okay, so somebody... Oh, wait, they're using dplyr? Okay, someone's got an answer down here. What? Okay, take your data frame, go through the mutate. Up, they're using the map double. Okay, I think you need to map a function into your mutate, perhaps. And then someone gave another answer, which they never replied to. Man. Random sites. Using parse text. Parse. Oh, and then they're storing into. Okay, so you need to parse it, and then let me grab this. Okay, let's look at this. I am like, I know I can do this, but I need to do, I know there's a way. And then, I'm just like, I know there's a way. Here's the name right here. Here's the name. So the name, we have it stored as X right now. We have the name stored as X. We have volume stored right there. Oh, what have we done? Structure, expression, volume. We got something. Yeah, exactly. I read a ton of cheat sheets. I'm always looking at it being like, okay, how does this work? What is this? Finding the right thing you want to do is often hard. Sometimes you get stuck and you're like, I'm just stuck. It won't work. We got something. We did store to it. Didn't really do what I wanted, though. Because what I want is I want this to be named this. Okay, wait, I have another idea, Connor. What if we rename something? What if we have a vector and we rename it? Here's my idea right here. We make a vector, a blank vector, and then we just go through here and we rename the vector. So let me see here. Renaming a vector using string in R. So let's create the vector to start. Rename, select a vector with a vector of strings. No. Rename. Oh, is it just rename? Rename X, replace. Okay, so there's a rename function. Okay. So if we go here to, let's create the vector 1. And we'll call vector 1 this right here. There's vector 1. We go to the rename function. Rename exists. It's part of dplyr. Do we need to go through some piping on this? Maybe we do. So we might need to go piping on this. Let's go here to vector 1, pipe through it, rename, and see if we can just put in here vector 2. And it looks like it's getting mad. Let's just run this code right here. Oh, let me get that thing on the rename again. Rename what you're renaming, and this is part of plyr. So we might want to call, do we have plyr loaded up? We do have plyr. Let's call rename from plyr. There's the thing right there. So we're going to go with vector 1, and we're going to place with vector 2, and vector 2 not found. Let me look how they're running it. Okay, I'll show you what I'm looking at. Okay. So they create the vector X. Oh, it's replacing levels. It's replacing, yeah, that's a good function right there. That's not renaming a vector. It's renaming elements of a vector. So string replace match patterns. Change name of vector to string. Change name of vector in R. Okay. String, I think, is confusing it. Changing the names in a name vector, no. The names of an object. So let's go right here. Brian's on a rabbit hole right now. Yeah. Oh, Victor has no names because it's not a name vector. Changing vector names. Someone asked us. Oh, G-sub. No, this is a named vector. View. Let me see if they're saying chat. Code to view object name in R. Oh wait, so I'm probably saying vector. So change name of object in R. How do I rename an R object? Cool. They're just saving over. Okay. I feel like it's so simple that Petrie would be like, come on, Brian. How to rename without copying. Trace mem. Oh, wait a minute. Are smart enough to not make a copy of the variable is the same thing, so just go ahead, reassign, and remove the original. Well, that's lame. Let me see. This is exciting office hours today. Did we just use rename? Let me see what we just used. No, we did just use rename. Rename is not what we want. Any named object. Rename Iris. Oh, wait a minute. Maybe it is. So you can rename for, wait, structure, rename. Oh, wait a minute. We're on something here. Structure of M. Okay, okay. 1. Oh. Let me go over here. Okay, cool. I'm just going in a rabbit hole. So we need to bring out this is what happens when Brian. Oh, it's got a dollar sign on it. So is that not the? We're back to where we started, I think now. We're literally back to where we started. And then we want to take this and save this. So what Connor's everyone saying? Probably end office hours soon. This has been Brian's rabbit hole of office hours right here, trying to figure out on these Fridays. All I want to do is turn string into object. Turn string name into object in R. Treat string as object name in a loop. Oh my gosh. Holy mackerel. You could create the call to blank and then evaluate it. Here's an example. Oh my gosh, someone's done it. Oh my gosh, Connor, this is it. Okay. So paste variable, whatever the string is that we're putting in right here. There's the name of it right here. And then this is going to be the iterator. So we don't really need that. We don't need the sep argument because that's going to be the separator for the paste function. And then the eval call. Ooh, so it's there. It's making a call to R for us. And then as.name x. So that's treating that as a name. And then the value right here. So I think we're just going to run it one iteration. Connor, we might have done it. We might have found the code we're looking for. So in this code right here, what's the whole point of this again? So paste right here, that'll turn this into a word. Let's make sure that grabs coefficients. That obviously grabs coefficients. It's just running that code down there. Eval, it's going to store into as.name. I think this is what they have right there. That should follow it. And let me see what Connor's saying. So I think I have everything I need. Yeah, I know, right? This is not how I usually code because I don't usually have to call an eval inside of here for it to evaluate this and make the call inside of R and then for it to evaluate the call. So this creates the call. I don't think we currently have a value. Yes, obviously. So it's saying that. We haven't even stored object X. But the value is just the way this looks. Let me store 4 as value or something. And just run this to look at how this call looks right here. Because I think here we'll store this into X. Because we've got our for loop and we just want to see what it does. Okay, look right there. Boom. That's so interesting that is what it's doing. I know, Cliff, right? This has been a huge rabbit hole. So then this is going to evaluate this. So when I run this right here, oh my gosh. Oh my gosh. Look at the screen. It has now run and done everything we're looking for. It's going to store into the name we create of X. So you could, take this right here and put it right here, but they're doing it in 2 steps, so that's fine. So now the whole point of this was to go through here, set this to I right here. Okay. So coefficients didn't get changed. Okay, so I is set to 1. That's good. So this should be creating coefficients. That's getting stored into X right here. And then when this runs right here, what's it doing? It's creating the call, because we have value set to 4. But, okay. So there's no value right now. So the problem is right now is it's not seeing the values. Connor says genius. We're almost there. We're just like steps away. We're at the door right now to where we wanted to be this whole entire time, which was just a really pointless endeavor in trying to do something random. It's all learning how to code is just pressing yourself forward and being like, where's that code I need? A lot of Googling. Like literally, remember in class I was saying in 475, you Google things, you find what you need, you fix it to what you want. Connor, how often do you Google code? Connor's out there working a hard job. Not a hard job, but working hard. Maybe your job's hard, I don't know. But Connor's out there working. How often do you Google code? How often you're like, wait, I need to do this? Like right there, just like on the money. You're Googling code all the time. You're looking up code. You're like, how did someone do this? How do I do this? Like Connor said, I would never thought of this. And this right here, this whole having R make a call for me and then using the eval on the call so that R knows to create this call statement, which is all it's doing is writing this code for me right here. And then I'm using the eval every single day. You have to know. Love having crowns. You have to know how to like search probably hundreds of times a week. Yeah. I'm always looking up new things. So the value thing is the issue right now. What are the values? Well, the values are going to be, let's go get the right values we want. They're going to be part of this right here. So we probably want, right now, I is currently 1. You can see it in the global environment. Oh, look at that. Oh, I think we've done it. Oh my gosh. Yes! Sorry. That hurt really bad. I slammed my teeth together. That hurt really bad. I was like a 6 or 7 on the pain scale. It was like a sharp stab. Once again, I did get oral surgery yesterday. It hurt really bad. Ow. Oh my gosh. I think we've done it, Connor. I think we've done it. We did not give up. Oh, I deleted that. All this work to do something which was utterly pointless. And for Brian to hurt his mouth. Really? How is red class not loaded? I was using it. Clear the environment, clear red class. That really, but now my tooth is actually kind of sore. It's alright, it's alright. It's what happens when you solve models and you get really excited and you make things work. You get really excited. But that like really hurt. I like slammed my mouth shut. We did it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where? Oh, you know the other things. The other things saved, and it's so smart. The other things saved as like the call right here, which it saved when it did this right here. I guess it created that call. Yeah, the for-loop's creating the call also. The QR is part of the model, it looks like. There's the QR, and look, this one up here to the list. This one up here is apparently this is empty, named list with nothing in it. So we just did it. And you know what we can do? Watch this. Boom. Connor, what have I done? Connor, what did we do right here? Connor saw it. Connor, what have we done right here? That if someone's like, oh, I want to go here and I want to create, a variable, and I'm going to go right here and I'm going to go right here and make my model. And this is one of the great things about what we're learning in 474. So Connor should know, and this is why the more you learn, you can do things like this. So we go right here. Now we go unlist model. Oh no, what happened? We got one more thing to fix. We're not done yet. Connor. 5, 6-letter word. Connor, what am I missing? What am I missing? What am I missing here, Connor? I'm missing a blank on this function. Come on, basic stuff right here. Come on, Brian. We're so close. And I'm missing something on this function because this function just does stuff. It doesn't do this. A big thing. We're so close. So close. I got my creative function, but it just spins its wheels. It's like... I gotta stop. Getting too excited. It's just spinning its wheels. It's like... But what are we missing? 6-letter word. Big thing we're missing inside of this because it just doesn't do anything really. It doesn't what anything. Return. Yeah. Oh. Super save. Ha ha ha. Sorry, Petrie. Oh, come on. You don't want a super save from me? It doesn't like super save. Man, I thought we could outsmart it with super save right there. So it's stuck in the function world. We need to get it out of the function world, Connor. So this thing it just created is stuck in the function world. It's like calling it in the function world, existing in function world, and then when function world goes away, it goes away. How can you save function environment? Save function environment in R. Okay, save function environment. Can I save the temporary environment of a function? Assign X. Someone's using the super save right here. Someone's pulling my super save on this. What the? That's the lo-fi hip-hop radio. I must have accidentally clicked on that. So someone's using super save. Why did super save not work? You can return the objects in a list or assign the variables inside the function. So you see they have X created right here. And then could we use a dot? But it doesn't know where to go. All right, let's just do something crazy. Assign, oh, wait a minute. Whatever it creates right there. This is a bad idea. I didn't like it. Might have to call quits on this one. I know we're just so close right here. We're so close. How can I save all the objects with the function's local environment? Answer. Save list equals. Oh, wait. So we want to, after we finish the for loop, let's save what it created. File equals environment. Someone's saying go right here and do this. And save the list. All names equal true. Didn't do it. Stack Overflow, you're failing me. And then they're saying load. E. Oh. No, that's close, but I don't like it. It did store everything we had right here. I just don't like it. It's pretty much the same output. Gosh, so close. I just had to go the extra step on this. Had to go one step further. One step further. Problem, I could super save them if they just didn't have a name. Like if the name didn't change every time. I'm just shocked super save doesn't work there. It's a bummer. Save function environment. How to write a result of a function in a global environment. No. So close. You think that? Yeah, that might do it. Well, so where should we put it? You're saying X super save into X. We'll just do this as time being right here. We'll just see what we get. I don't think this is going to get the desired result. We get model right here, okay, which I think is the last thing in the list. So that's the last name right there. We get model. So we're on to something that does show super save is leaving where we have. So we need to capture what this was. What the thing is, the issue is this changes as it goes through, which this is currently called X is currently model and the names of it. So this is meant to store something as model. So if we go here as dot name and problem is we need the call, and because this changes, the problem is that this changes right here what x is, and so it's calling it x, but it needs to change, which means we're using this again. We're like so close, Connor. After it runs, it's creating the environment. I don't know if I can capture the environment. I want Petrie to swing in and be like, here's how to solve it. I'm going to do this for another 5 minutes if I don't get it. Put a 5-minute timer on. Let me put on some chill music and see if we can solve this. Connor and I putting our heads together, having a hard time with this. Oh, we need some more chill music than that. Here we go. All right, chill music right now. Trying to solve this. See what we're getting right here. So the goal is... See, it's already the issue is this works, just not as a function, because I really want to just use it as a function down here, and then, like you said, send it to Petrie. And be like, hey, here's how you unlist your function, because the function is kind of weird when you use the unlist on it. You would just think super save would work right there. Gotta love super save. You would just think it would work. Is it getting mad? Let's see if it's working at the start of this. Let's just see if it works for the very beginning and it's mad about it. Okay, it's not working at the start either. I changed the loop. So it's not, it's just in general. You see it got mad at coefficients. X super save into position I. Okay, let's try that. Let's remove this super save. And so that'll save into the position of the X vector. Floss your teeth. Oh. We get something out of it now. Oh, wait, did I change it to just... Okay, so that created the names of the vector. That stored all the names for us now. Which is just going through here and replacing. Okay, wait. I mean, at least we get some output from this now. Is that cool? Vector X just has the names of it. Because the whole point of this is... here, let's go grab it. We'll come back forward in time. Let's rewind time here a little bit and go grab the thing we created that actually worked. And then we'll come back forward in time after we go back to the past. Let's not function it yet. Here we are in our little universe before we destroyed the world. And here we are back in the future. And the whole point of this is that we can take, for those who... Oh, good. I thought I hit something right there. That's the whole point. So that works. That works 100%. That does what we want it to do, but we just can't get into function because when we go into the function world, the function output we need to return on. You know what, Connor? I'm just going to do something crazy. Problem is return ends the function, but will return stop the for loop. So now we have something capturable right here, but will return stop the for loop, which I'm afraid it will. Will return stop the for loop. So we're just going to go here to function. Or let's keep this one nice and neat down here. Okay. So the question becomes, if we throw the return on this, is it really just that simple? Create an if? Oh, if like... Well, okay, so you're saying like if you reach the max length, do a return? Like, is that what you're thinking maybe? Like what will the ifs... I gotta be careful. If on the length, yeah, like if it reaches the max length. Okay, we got the function created. Let's remove this. Yeah, if it reaches the max length, then run a return. But how will it know what everything is? Okay, let's try the function. Unlist model. This is a bad idea. Sometimes you try something and it works. Yeah, I didn't do it. Why would it not return just the one thing, though? Because it's storing to the global environment. I mean, it's storing to the function world. Leave the function world. It's not going to like it. It doesn't like it. It said, no, I don't want to leave that function world. I'm happy here in function world. But if I run the, like, if... I think we'd have to create the object outside the loop scope. Oh, so, okay, so leave the loop. I'm putting another 5 minutes on this, and I'm going to end. So leave the loop. Could I nest the loop? I gotta eat some lunch here soon. Oh, I really do need lunch. Gotta take my moxicillin. Then super save. Okay. So we need to get the name of the object. Okay. So, well, the problem is if we leave the... Okay, so we gotta leave the loop to save outside the loop. Save the cheerleader. Save the world. Let's think about the final end of the loop. Let's see if we can capture the last object. So let's leave the loop right here. At the very end of the loop, we have something called this name right here. So at the very end of the loop, we have the final object called a certain name. So... yeah, I know, right? So wait. Let's leave the loop. And then at the final end of the loop, let's super save. Connor. It worked. We left the loop and we were able to super save. You can't super save inside of a loop. Connor, we've made progress. So now the question becomes, how do we get it to super save every time outside the loop, but then restart the loop? Like, I don't know if there's a code to say, hey, loop, stop running so we can super save, but then go inside the loop. Or we, like, have to write loops, like... It's just ridiculous. Like, you'd need to write... Like, literally, you know what? I have the answer, and it's not a good one. I gotta go down. It's time for some Stat to One Hacker Man. I've got the answer, Connor. The answer is we don't want a loop. So, we're just gonna destroy this loop here. Bye-bye, loop. We don't want you anymore, loop. We don't need you here. Guess what we're gonna do? We're going to take this. We're gonna take this right here. We're going to eval. We're going to do this. We're going to do this. But can you do this? Here we go. We're going to go right here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, did we do it? Oh, yeah. Oh, yeah. I know 12 right there. We got unlist model. We run this right here. Guess what? You're out of here. And now we go to unlist model. Guess what we do? Boom. It broke. Object X not found. Where's my X object? Oh, wait. We need a super save now. How did this not work? Connor, how did this not work? We are so close. Yet so far. Connor, we're close. This is the Hacker Man moment right here. We're running out of time on office hours. I took my code. Always coding those little bits. Object X not found. Function as.name X. Oh! Sometimes when you don't copy your code properly. I will make this work. I will make this work. This is happening today. Puppet Shark, is this happening? This is happening. I don't care if it has to look like this. It might not look pretty, but it's gonna work. It's gonna work. Show me. You worked a moment ago. Let's go smaller. We did too much. We didn't code in those little bits. Second cup of coffee's starting to wear off here. It worked! The shark got you. It worked right here. Wait. Oh, it's I. No way. Okay. How did it work? How did it work for 1 second? I had such faith. Does it only work on model? If this works, my head will explode. Okay. I think we hit the end, Connor. That's not fair. That's not fair. It works on model. So it works on model. Do you think maybe the regular save would work right here? Like maybe certain ones need certain things? These it didn't save. It's still in the function world. Yeah, I think I gotta go get some lunch and... Man. It just works on model. It might work on other things inside of here, but we lucked out. It worked. And does it work on other things like this? Peach will probably be like, Brian, this is so easy. It looks like it probably would work. It works on that. That's 12, 11, 10, 9. I don't know if it would work on number 9. Yeah, no, awesome. Have a fun day. I appreciate it, Connor. I had a lot of... I'm so hungry, too. This is literally what I'll do. Okay, it works on 9. And that's what it's supposed to store. So it does it to things... Miss you too, Connor. Anytime, man. I have to put this down. The super save is working right there. We definitely did not do this an easy way. If this works, this will be bad for me. Because I don't want this to work. Okay, good. It didn't work. Well... Hope to talk to you soon, too, Connor. Anytime, man. We got defeated today, but we're not defeated every day. We're not defeated. We'll come back here. We'll code more. A lot of fun right there. Brian's going to eat some lunch. Yeah, you're welcome. Thank you so much. I got to watch out closing my mouth. Like 3 hours of oral surgery yesterday. Not so fun. So anyways, I will be back. And maybe we'll figure this one out. Let me save this as like solve sometime. Solve this sometime. I appreciate the question. Brayden, thank you so much. And Cliff, thank you so much. Literally, if you enjoy doing stuff like, do you think I was doing that because I hate it? No, I want to solve it. I love solving problems. And so to me, that was fun and interesting to see what we could do. and it was fun, like working with Connor. And you don't have to love coding as much as I do, but I really wanted to solve this, but I gotta go eat some lunch. The answer is probably just so simple. And you see Connor's like super save it, and I know what we're doing. Check out some dplyr, check out some perk. We're just throwing a million things at the wall, trying to get to stick and get it to what we want. And really, we're doing something utterly pointless, and that's perfectly fine, because if you learn how to do the pointless things, you can learn how to do the big things. With that, it's lunchtime. Grab some lunch, everybody. Enjoy your time. I'll be marking the videos later. Got a lot to catch up on this weekend. Email me if you got questions. Talk to you later. Bye.